Hello, my name is Maria Muniz, and I'm a Senior Manager for Technical Sales and Support here at ChemTreat. I also provide our customers with water and wastewater treatment solutions. And today I'm going to talk to you about the basics of coagulation flocculation, and then a little bit about a product that we have in the product line. So let's get started. So in the process of coagulation flocculation, we use a lot of inorganic coagulants. And those are commonly used: aluminum chlorohydrate, alum, ferric sulfate, those kinds of things. The problem with these inorganic coagulants is that many of them have chlorides and sulfates. So one of the things that I mentioned is that we're going to be looking at a new technology that ChemTreat has that eliminates that issue. So first, coagulation. What is coagulation? Well, it's a process of neutralizing the charges that help stabilize the colloidal particles in water and keep them suspended. Particles, when they come in contact with water, they have this surface charge around them that keeps them suspended and keeps them from settling. And the whole goal of coagulation is to bring particles together and then help them separate from water. So this is a representation of what a particle might look like in water as it's suspended. The brown spheres are the particles, and the blue haze around the particles is the surface charge, the anionic charge around the particle that keeps them suspended and away from the other particles. So in this particular case, they're separated. They continue to stay suspended because there's nothing to bring them together. What we do with coagulants is we help neutralize those charges. And this slide shows how when you add a coagulant, how it works around that negative charge around the particle. So the first set of spheres or particles here will show the blue haze, which is the anionic charge. And then the addition of a coagulant is represented by these little pluses all around. These pluses will help neutralize the charge around the particle and allow that haze around the particle to reduce. As coagulant is added, more additional chemical is added, then the haze around that particle reduces and the particles come closer together. And that's the goal of the coagulant, is to reduce the surface charges around the particles so the particles can agglomerate. And what happens? Well, as these particles come together, they form larger flocks. And that's what we show in this representation. You've got a number of flocks comprised of a lot of little particles. Flocculation. Well, the process of flocculation is the process of bridging these coagulated particles together. So we form these individual pin flocks made up of a lot of little particles. And then flocculation then is the process of using a flocculant, a high molecular weight polymer, to wrap all of these flocks together, to bring them together. We call that bridging. Bridges all of these individual larger flocks into one large flock. And the larger the flock, the larger the diameter of the flock, the faster it will settle. So we will use coagulants and flocculants together to bring the particles together and then to grow the flock size so that it can separate in your treatment system. Pure flock coagulants are specialized products that work similarly to the organic coagulants, but can also replace inorganic salts. And in addition to the charge neutralization, they also provide this sweeping effect on residual pin flock that may remain in your water. So what are the advantages? The advantages are that you provide less chloride and sulfate into your makeup stream. And because you're using less of it, you are actually impacting the amount of sludge that you're generating. There are low handling hazards in using this product because it's not an inorganic, and the feed rate is much less than you would see with inorganic salts. And of course, the performance cost advantage over organic coagulants is good. Where do we find applications for this product? What we've seen is that these products are particularly good in oil wastewater treatment applications. So DAF, CPIs, let's say, also. Any application where you're going to have a high oil and grease content. These products tend to do a very good job in separating out the oil. So what the advantages is, of course, you're producing less sludge. That's important because typically in these applications, these sludges are considered hazardous. So if you're producing less sludge, that's a less hazardous sludge that you would be producing. Also very effective as dewatering agents, and they help increase the percent solids in your cake. And they significantly decrease the sludge volume, as I indicated earlier. Also, you can use these products in applications where there's a TDS restriction. Because these products have low to no sulfate or chlorides, they are ideal for those applications, such as raw water clarification or even just wastewater treatment where you have an issue with TDS restrictions. And then, of course, the handling and safety concerns. They're not inorganic, don't contain chlorides and sulfates, and are not corrosive for your employees to handle. We've had much success with these products in steel mill applications. As you can see in this slide, we have 9 steel mills that are currently using PureFlock products, refineries, automotive, food and beverage. They're all using different products for the various applications, but we're seeing very good success in these. Just want to recap. We talked a little bit about coagulation, flocculation, what the process is, and how coagulants and flocculants work to bring the particles together and separate them out from wastewater. And then we touched on the technology that ChemTreat has, which is the PureFlock product line. There's a variety of products. Some of them are a combination of inorganic and organic, and some of them are purely the natural product. Thank you again for your time. And should you have any questions regarding the information provided or want to discuss something further, please don't hesitate to send me an email. Thanks again.